So you are going to run your 220, your hot wire, into a breaker, protect it somehow, breaker or fuse, and then run that to the top side of your motor starter contacts. Find a 2-pole, or if you have a 3-pole, just use 2 of the contacts out of the 3. And from there, you're going to run it through your overload relay. And from your overload, it's going to go to your single phase motor. And do the same for your neutral wire, through the contact, to your overload, to the motor. And then make sure you ground your motor also. Before I continue on, obviously this is not USA voltage. This is in a different country, and the requester said that they run 220 on their hot wire with a neutral. So that's why I have it drawn out that way. So up here, the high voltage side up here is our power circuit. And then from our power circuit, we are going to use a power supply to bring that voltage down to a safer voltage level to control our circuit. So find a power supply that's capable of bringing in 220 and then rectifying it to 24 volts DC. And then we're going to tap off your hot wire, your L side, and wire it into L. Same for your neutral. Tap a neutral in to your power supply to power it, and also ground it. Then on our output side, we will now have 24 volts DC, which is a much safer voltage level to be working with. Then on your 24 volt positive, bring it in again, protect it, put a fuse in line, and on our first rung was where you're going to meet your selector switch. You want a 2-position selector switch. In position 1, it's going to close this contact up here, and our focus will then be on this first rung. If you want to be in position 2, we'll focus on this contact down here, and then you will be down on this rung number 3 here. So let's focus on this first position, where it's going to be running off a low level start and a high level stop. So your 24 volts comes into your selector switch, contacts are made, 24 volts makes its way over to your low level start float switch, and it also parallels down to a set of normally open contacts, auxiliary contacts on your motor starter. Your low level start is a normally closed, held, open float switch. So don't get this symbol confused with a normally open float switch. This is actually a normally closed. It is shown in the state that it is intended to be used for. So this low level start is actually normally closed. The contacts are normally closed, but there's water level in that tank that's going to keep that float open. So as long as the water level is above that float, it's going to cause that float to break open the contacts. So under the operation that you want it to be is when the water level drops below the float for the contacts to close. So let's go ahead and step aside for a minute to take a look at the drawing that I made here to give you a better visual. So over here you have your inlet pipe coming in where it's bringing in water. You have your pump in your motor assembly, and then you have your discharge side from your pump. Put a check valve in line so it can't backfeed back into the pump, and then you have your discharge pipe into the tank. You have your high level float switch. This float switch is going to stop your pump from pumping water into the tank, because once the level rises and it hits the high stop, it stops that pump. This is your low level start. So once you drain water out and the water level starts coming back down and it goes below the low level start float switch, the contacts go back to its normally closed position. Again, when the water level rises, it causes the float switch to break the normally closed contacts open. That's why we have here in the as is state. It is actually a normally closed, but the water level rises and it breaks it open. It keeps this low level switch open here, and then once the water level drops back down and there's no water pushing on that float to break open the contacts close again. So once the 24 volts DC makes it to your low level start, it waits for the water level to come down. So on your tank, if the water level is below this, it's going to cause the contacts to close because there's no water level pushing up against it to break open the contacts. So right now, the water level is below your start, your low level start float switch. So these contacts will be closed. It will drop back to being closed. 24 volts makes its way over to the high level stop. A high level stop is a normally closed float switch. So being that it's normally closed, the 24 volts goes right across it and energizes your motor starter coil as long as that overload is not tripped. The negative side on A2 makes its path back to your power supply. The 24 volts makes it to the coil. It excites that coil, and it will then close this contact right here to latch itself in. It will then continue sending a 24 volts to your motor starter. Since your motor starter is energized, it will also close the main contacts up here, bringing in your 220 and your neutral through the overloads to energize that AC motor. That single phase motor will then start and the action begins. You have your inlet water coming in, motor is energized, starts pumping, goes through the check valve and starts pumping water into your tank. And then the water level starts rising and it starts pushing that low level start, which will then now break the contacts open. So if you come back down here, this now breaks open. It cuts off continuity through this path, but you still have your auxiliary contact holding in your motor starter coil. So electricity will take this path. You have this path to take your 24 volts to keep your pump and your motor energized to keep pumping. The water level is going to keep rising. It's going to come up, and once it hits this high level, it's then going to push up against this float switch and break the normally closed contacts open. So you come down here, this normally closed set of contact will then break open. It's going to break open, cut off continuity to your motor starter, which then cuts off power to this also and opens your circuit back up. And that is how the pump motor assembly then stops. And then you also want it to where you can bypass the float switch to just pump water in, and that would be in position 2. So if you would flip your selector over to position 2, you will have 24 volts coming through this set of contacts, and these contacts will no longer be open, they'll be closed. So 24 volts can make its way over here, and it's going to share the same parallel of wire number 3, and go through your high level stop. As long as this high level stop is not open, it will automatically energize your motor starter and start your pump in action. If the water level is already high enough where it's pushing this high level stop open already, this will be open right here, and even if you have it to start your pump manually, you can't, because this path will be cut off and you cannot send 24 volts over to your motor starter until that high level drops back down. So there you go, bud. A little visual to how I kind of visualize what you were asking for, and power circuit, control circuit. I hope this helps you out. Until next time, deuces.